Okay, so today we're going to talk about trigonometry. Trigonometry comes from triangle geometry. And so it's all based upon, initially, how the angles and the sides of a triangle interact with each other. In a triangle, you have three sides. And specifically, we're going to start talking about right triangles. A right triangle has a right angle in it or a 90-degree angle. In this example here that I have drawn, I have a right triangle. The side that is opposite the right triangle is called the hypotenuse. And the hypotenuse is always going to be the longest side on any right triangle. And then you have two other sides that are going to be labeled the adjacent and the opposite. Now, those two may switch depending upon the angle that you're working with. In the example that I have up here, I've drawn in this symbol here. This is the Greek symbol theta. And we're going to talk about angle theta, which is actually angle B here in this case. And I've written in the words opposite and adjacent. The opposite side from our angle theta is the side that actually physically does not touch the angle. The adjacent side to angle theta actually does touch the angle. So it's all relative to the actual angle that you're working with here. If I was working with angle A here in this case, maybe I wanted to call that angle phi. Then the opposite and the adjacent would switch in this case. If I had angle phi, what's labeled here as the adjacent would become the opposite, and the opposite would become the adjacent. Okay, everybody clear on that? So it's all about the angle that you're working with here. Now, we have initially three trig functions that we can work with. They are sine, cosine, and tangent. For sine, we write and abbreviate SIN, angle theta, and sine is equal to the ratio of the opposite side divided by the hypotenuse. The cofunction of sine is called cosine. And the reason why they're called cofunctions is because they're talking about two angles that are complementary to each other. Remember, complementary angles add up to 90 degrees. So here, our cosine of angle theta is equal to the adjacent over the hypotenuse. And then tangent represents the ratio of the opposite divided by the adjacent. Now, tangent can also be written as sine of theta divided by cosine of theta. That's the identity for tangent, if you will. One memory trick that you can use to help you memorize what these are is SOHCAHTOA, which you may or may not have heard before. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And so this memory trick can work well if you remember that some of the letters are silent. So if that's the case and it's not working well for you, you can also use this memory trick where you write down sine, cosine, and tangent. And remember that Oscar had a heap of apples. And now we'll say Oscar had a heap of apples, OH, AH, and then OA. Regardless, whatever memory trick you want to use to help you remember which trig function to use, go ahead and use it. Okay? Now there's three other trig functions as well. There's cosecant, there's secant, and cotangent. And these are all just reciprocals of these three. I have a video for that, so I'm not going to rehash that here. When we're talking about solving a triangle, what we're asking for is the length of all the three sides and all of the three angles. Now, in every triangle, you have to have at least one side in order to work with it. Some cases, you'll have two sides to figure out all the other angles, or you'll have a side and an angle. But you have to have at least one side. So whenever we do our trig functions, you identify which variable you want to work with first. In this case, let's work with x. We're given 40, and then we're given 3. So I have this angle here. I have the opposite side, and I'm looking for the adjacent side. Okay, so I'm involving the opposite and the adjacent. That means I want to use the tangent function. Okay? So I'm going to identify that tangent function first, and then I'm going to write the tangent of 40 degrees is equal to 3 divided by x. Now, solving for these, you can use a little trick. What I do is I set it up as two proportions that are equal to each other, and I write tangent of 40 divided by 1. What this allows me to do now is when you have proportions, you can switch the numerator and the denominator on opposite sides of the equal sign. So I can switch the x and the tangent of 40. So I can switch those two, and I can write this as x is equal to 3 divided by the tangent of 40 degrees. And I've solved for x in this case. When you take out your calculator, you want to make sure that it's in degree mode. So for those of you who have the TI graphing calculator, you want to go to mode, and you want to go down to where it says degree and press enter and make sure that you select that. If you have a different calculator, there's usually a button that says DEG on the top, and then it'll indicate with D or DEG in the window above. Go to mode. Select degree, you got it. Anybody need help getting in degree mode? You guys good? We're going to be working with degrees and radians, so we want to make sure that we're in the right mode. Great. So let's do 3 divided by tangent of 40. I'm going to get, 3.58. Okay? Let's go find y. Here it is. Y is my hypotenuse. I know my opposite side, and I have my angle. So I need the trig function that works with the opposite side and the hypotenuse. All right, so I go back, and that's going to be sine. So now I'm going to write sine of 40 is equal to 3 over y. Again, I'm going to use my powers of proportion to switch the y and the sine 40. I'm going to get y is equal to 3 divided by sine of 40. And that's going to round to 4.67. You might be tempted to use the Pythagorean theorem once you have two of the sides, and you can. But I would actually encourage you to go back and use a trig function every time. And the reason is because this first number that we got here is an actual approximation. So you don't really want to use that because that's just going to carry your error forward in your further calculations. It's actually easier to use the trig function as well, rather than using the Pythagorean theorem. It's actually a little bit less cumbersome to use the trig stuff. Okay? Let's look at another example. Here we have x, and we have a triangle, and our hypotenuse is given as 10. So I'll give you a second to figure out which trig function you need to use. They're going to be sine, cosine, or tangent. And the answer is it's going to be sine. So I'm going to write the sine of 40 degrees is equal to x divided by 10. Here my variable is going to be in my numerator. So I don't have to do the old switcheroo when it comes to solving using proportions. All I have to do is move the 10 up over here in front of sine. And that rounds to 6.43. Moving the 10 over there is essentially multiplying both sides by 10. So I'm not breaking any rules here, not creating any new ones. I'm just making it a little bit easier. Okay? In all cases, when you do your right triangle trigonometry and you're given an angle, you're either going to move the variable, you're either going to switch them, your numerator and denominator in one example, or you're going to move the number up in front of the trig function. Those are the two procedures that you will have when you set up a trig function, if you have an angle. Now, if you don't have an angle and you have to find it, you're going to have to use an inverse trig function. Let's take a look at this example that we have right here. Here I'm given a triangle with just two sides of 3 and 4. And I have to find that actual angle. So the angle in question is theta. I know the adjacent. I know the opposite. So I'm going to use tangent. And I'm going to set it up as the tangent of 4 divided by 3. So now my variable is actually contained within inside my trig function. So what I have to do is use the inverse trig function. And I'm basically taking the inverse trig of both sides here. So essentially I'm doing the inverse tan over here and the inverse tan over here. These two are going to cancel out because they're inverse functions. And I'm going to get theta is equal to the inverse tangent of 4/3. This -1, by the way, indicates that it's an inverse function and not the reciprocal function of cotangent. I know sometimes that the notation can be a little bit problematic. If you have a graphing calculator, you're going to type second tangent, and it'll say tan -1. I'm going to do 4 divided by 3, and that should give me an angle of 53 degrees. If you're using a phone or an old school scientific calculator, you'll do the 4/3 first, press enter, and then do the second tangent, and then that will give you the inverse tangent. Okay? Questions on that? Okay. Trigonometry is also going to involve something called the unit circle. The unit circle is called that because its radius is equal to 1 unit. Hence the name, the unit circle. And what we're going to be interested in is finding the sine, cosine, and tangent values of any coordinate point as it travels around the unit circle. We traditionally start off the unit circle right here at this point, and then we can move that point counterclockwise around the circle. So we start here. This is going to be 0 degrees, and then we can start rotating counterclockwise to 90 degrees, 180 degrees, 270 degrees, and 360 degrees. We don't have to stop there. The wheels on the bus can keep going round and round and round, okay? And then you just start adding up those angles. So you can have 1080 angles or degrees, which actually amounts to 0. That's 3 trips around the circle, okay? So understand that you can have this angle go around in a positive direction, or you can have the angle go in a negative direction. But you're always going to stop somewhere on the circle. You just have to figure out where it is on that circle and then translate it to an angle between 0 and 360 degrees. Okay? Now, we want to find the sine and the cosine and eventually the tangent of any angle that's going to be around that circle. If you have a calculator, you can just type it in, and it'll give you a numerical approximation. But what we're really interested in for a lot of these angles is the exact value. And that's going to be a square root of something, unless it's going to be a simple rational number. The way to find that is use the properties of 2 special right triangles. The first one is the 45-45-90 triangle. We're going to give it a hypotenuse, a length of 1, so that's the radius of our unit circle. And if that's the case, then the sides are going to be the length of square root of 2 over 2 and the square root of 2 over 2. If we have a 30-60-90 triangle and the hypotenuse is a length of 1, its short side is 1